All right, properties of real numbers, section 1.2. Yes, we are in Algebra 2 here. Today essentially is going to be all the properties of why we can do the different sort of shortcuts and arrangements of numbers that we can. For the most part, it can be review. You've probably talked about properties of numbers in almost all math classes dating back to almost 5th grade. Every year they might have added one or two properties. But it should be a lot of review for the most part today. The properties of numbers that we first started with here. The commutative property. There's the commutative property of addition and multiplication means I can flip two numbers or two sets around and I'm going to get the same answer. So for example, A plus B is the same thing as B plus A. Well, to think about that numerically or with numbers, it's like saying 1 plus 2 is the same thing as 2 plus 1. And in the back of your mind, you're like, well, yes, I knew that. Okay, so property of addition, commutative, I can flip two numbers around, adding or multiplication, and I get the same. All right, same thing holds for multiplication. 2 times 3 equals 3 times 2. Okay, 2 times 3 is 6. 3 times 2 is still 6. We're going to get the same answers. Associative property. Now, the difference between commutative and associative is commutative is just talking about two specific elements here. Associative now is more than two. So now I can rearrange 3 or more individual parts, and I'm still going to get the same answer. So, for example, it has A parentheses A plus B plus C equals A plus B plus C. So to look at that kind of numerically, 1 plus 2 plus 3 is the same thing as 1 plus 2 plus 3. Okay, it doesn't matter. You can arrange a lot of different things with addition and multiplication, and you're still going to get your same answer. All right, but the difference between commutative and associative is the number of elements that you're kind of adding or multiplying together. Commutative is just 2. You're flipping around the order that way. Associative is the grouping. I can rearrange the grouping of it, and it's going to be the same. Distributive property, talked about that in the warm-up. Anytime you see this set up right there, and it should be coming up here soon, number in front of parentheses, the thought process to go through your mind is distribute. Anytime you see that, you want to think distribute. Okay? And now there is no distributive property of addition and multiplication. This satisfies both. Okay? So this satisfies both of them because there is multiplication and addition going on in there. All right, and again, distribute means you're going to be multiplying throughout. All right, you'll hear me say that a lot throughout the course of this year. Distributive property is one of those things that a lot of students forget, mistake, because they see the parentheses, they want to do something different right away. But you can multiply throughout. All right, identity property. Identity is just saying that, hey, with addition, if I add 0, I'm going to get itself. Okay. A plus 0, anytime you add 0, you're going to get the same thing, 1 plus 0 is still, in fact, 1. Okay, that's the identity property of addition. Multiplication now, the multiplication part is we're multiplying by 1. 2 times 1 equals 2. Can anybody tell me why you don't use 0 for the multiplication part of this? Because it'd be 0. I'm not getting itself now. Now I'm getting 0, which is something completely different. All right. Inverse, okay, the inverse property of addition is you're just basically finding the opposite, okay? So if you think about it here, A plus its opposite, so A plus negative A, I'm going to get 0, okay? And the inverse of addition is opposite. The inverse for multiplication would also, or be a lot of times called the multiplicative inverse, and it's also called the reciprocal. Okay, multiplicative inverse, or also called the reciprocal. But essentially, A times 1 over A, you'd be flipping it. Okay, reciprocal is you flip the numerator and the denominator. So, for example, here, let's say I have, the number 2/3. Well, the reciprocal of that would be 3/2. You're flipping the numerator and denominator. And then when you multiply those, that's when you get your product of 1. Okay. All of these are the properties we're going to be focusing in on today. Questions on them? Have you seen these a lot in all your other classes? A lot of review for this part. Okay. Next part here. We're going to find opposites and inverses. All right. Opposites, everybody's like, yeah, I can do this. Been doing this for a while. It's the inverses that usually struggle, that there's some struggle for some students. And it's not the fraction inverses. It'll be like number 1. And I'll tell you right now, you might see number 1 again, coming up on a quiz or a test possibly. That's a problem I will probably throw out there just because it is one that students forget about. Number 1 here, I have negative 3.2, negative 3 and 2/10. What would the opposite of that be, Colin? So if it's negative 3.2, the opposite of that is? Yeah, positive 3.2. Okay, and again, opposite is not where people are going to make the mistake. It's this inverse that people make the mistake. Okay? It is a decimal. Where a lot of people want to make the mistake is they go, oh, I can just do this. Negative 3.2. Does anybody know what's wrong with that right there? What is wrong with that setup? It's actually just 2 things wrong. What can you not have in a fraction? Does anybody know? What did you say? Decimal. Yeah, I cannot have a decimal in a fraction. Okay? So we have to change this into a fraction first. Does anybody know how to change that into a fraction? What is that placeholder right there? Sophie, what's the placeholder that I underlined? That is in the what placeholder? The 2 is in the tenths. Yeah, that right there is the tenths. So to write this as a fraction, I say negative 32, get rid of the decimal, over 10. Now I get rid of the decimal. Now can I flip it around and find the reciprocal? Yes. Okay. Sean, what would that be as reciprocal then? Negative 10 over 32, you bet. And that can simplify, so I will simplify it. What does that simplify to, Shane? Very good. Correct. And again, the big thing there to remember is you cannot put a decimal in a fraction. You've got to change the decimal to a fraction first, then I can do the reciprocal. Okay, and again, you will probably see a problem like that again. Number 2, 3/5. Opposite of 3/5 is what, Phil? Opposite first. What's the opposite of a positive? Yeah. And the inverse then, Phil, which I think you said the first time, the inverse of 3/5 is now then what? That is 5/3. Okay, opposite means I'm changing signs. Inverse, I'm flipping my numerator and denominator around. All right? Try number 3 and 4 here. Opposite of number 3, negative 9/4. What would the opposite of that be, Colin? Yeah, positive 9/4. Okay, inverse of negative 9/4 would be what, Jarrett?
Negative 4/9.
Negative 4/9. Very good. And again, the fractions, we're all starting to see the fractions. A lot easier to do inverses with fractions. Now comes number 4. Opposite of 3.25 gets me what, Jack? Negative 3.25. Okay, now comes the inverse again. Yes, we have a decimal. I have to think. What is the last placeholder there? What am I going to write this all over, John? Yeah. So I have 325 over 100, which makes my inverse what then, John? Let's go positive, because I'm still doing regular, right? Positive 100 over 325, which simplifies to what then? Does anybody know what that simplifies to? Garrett? 4/13. That is 4/13. Nice job. Again, it's recognizing that placeholder right there. To get rid of the decimal, write it as a fraction. Another way some of you could think of it is, does anybody know what 0.25 is off the top of their head as a fraction? What? A quarter. So you could just say, oh, well, that's just 3 1/4. And change it from there as well. There's a lot of different ways to go through all this. Okay? Next, we're going to talk about the properties. So those properties we wrote down earlier, the commutative, associative, distributive, identity, and inverse properties here. We want to identify what properties are actually being used here. So number 5 says I have parentheses 6 plus 3 plus negative 2x equals now bracket 6x plus negative 2x plus 3. So I'm rearranging the way I'm trying to add. And why am I trying to rearrange here? Well, I'm trying to get my variables or my like terms together. So I can rearrange to get my like terms together. Who knows what property is kind of being played here? It's more than 2 elements. John? That's the associative property. Yeah, because there's more than 2 elements, that is the associative. There we go. And if you want to get technical with it, that'd be an associative property of addition. Yeah, if you want to get technical, associative property of addition. So I can rearrange it to put my variables or like terms closer together so I can see how I can combine them. All right, number 6. I have 2 times 3.9 equals 3.9 times 2. Just flipping 2 elements around. If I flip 2 elements around, I'm using what property would you suppose, Ethan? That is the commutative property. Yep, commutative says I can flip 2 of them around, and I'm going to get the same answer. Okay, that's very helpful for adding. So a lot of times multiplying, depending on what you're multiplying. But that'd be the commutative property of multiplication. Number 7, okay, 3 parentheses 4 times pi equals parentheses 3 times 4 times pi. So again, multiplication now, if you see what's going on here, I'm flipping around the way I want to multiply. More than 2 elements. I have 3 elements here. What might be the property in this one? Jack? Associative. That is associative. And again, on a problem like this, yeah, it'd be a lot easier. I would suggest multiplying 3 times 4 first, and then pi. So yeah, that's the associative property of multiplication. Try these 3. Oh, wait. There it is. Try these 3 on your own. Number 8. Again, anytime you see this setup right there, what's going to be your thought process, Reagan? What property is going on there?
Distributive.
Yeah, that's the distributive property. And distributive property does not have an addition or multiplication. It's just distributive property. Number 9. 3 times 1/3 equals 1. Sean, what am I getting there? What property is being used? Yeah, I'm multiplying by an inverse. So I have the inverse property. And last but not least, number 10. Andy, what property is being used in number 10? Yeah, I'm starting with 5 and I'm ending with 5. That is the identity property. All right, next. Pretty remedial so far. A lot of review. All right, number 11 now. And I'd like you to use some mental math on these as best as you can. We talked earlier in the warm-up about the 10%. Okay? What is the kind of quick shortcut in finding a 10%? What do I do, Sage? Yeah, in order to find 10%, so for example, 10% of 78, I'm going to move the decimal in my annotation here. Move the decimal and I get 7.8. You can get to almost any percent just by using the 10% kind of shortcut. I'm going to show you how to do a lot of those today. Okay, because 10%, again, is probably the easiest of all the percents that you can do. So number 12 here, I have 5% of 36. How can you get to 5% using the 10%? What's a way you can do that, Jarrett? Yeah, 5% is nothing more than half of 10%. So to think about that, like you said, I'm going to move the decimal and get 10%. So 3.6. And then I take half of that. Half of 3.6 is what, Jarrett? 1.8. And that is then 5% of 36. Again, using 10% to get to a lot of different percents is kind of a shortcut way. 13 now, a little different. I want to find 15% of 50. Using 10%, how can I get to 15% of 50? Phil? Got an idea? John?
So you find 10% and then you add the 5%.
So 15% is really 10% plus, I'm going to say half of 10%. Does that work for you?
Yeah.
Because what's half of 10? 5%. So I take 10% plus half of 10%, and I can get 15%. So 10% of 50 is what, Andy?
5.
10% of 50 is 5. Half of that is what, Andy?
2.5.
Add those together, and I find out 15% of 50 is what, Andy?
7.5.
7.5. And again, I can do all that mentally just by knowing how to find 10% of a number. All right, last two here for you. Try and do these. Try and do them mentally as you can. Think about a way using 10% to get to all those different solutions. All right, so using the 10% method here. Who feels confident they have 14? Bailey, you made eye contact first. What do you got? Yeah. $2.12 if you want to think about it that way. But yeah, 2.12. Okay. 10% of 42.4. So if I can find 10% first, that's 4.24. And then I do half of that to get 5%. So that's just dividing by 2. And I get 2.12 using that 10% method. 15, find 30% of 25. How can you get to 30% using 10%, Sophie? Yeah, 30% is nothing more than 10% times 3. So I take 10%, 2.5, times that by 3, and I get what, Sophie? 7.5. You can get to almost any percent from 10%. Anything that ends in a 0, you can just take 10%, times it by whatever is in the first place there. Okay? And here is your assignment.